Hope you are all fine and have gone through all the previous tutorials. Today we will discuss on how to construct LALR parsing table. Now this LALR, it stands for look ahead LR, and LALR parsers are often used in practice because they are smaller than CLR parsing tables. Okay, and the number of states in SLR and LALR passing tables are equal, but LALR can recognize more grammar than SLR passes. Okay, and compared to CLR, they have small number of states, and also they can find the answer fastly compared to CLR. Now, Yak is an example of a parser creates an LALR parser for the given grammar. Now, the basics for construction of LALR parser is our CLR parser. So once you have a clear understanding on how parsing is performed in CLR, then you will understand LALR very quickly. Now, a state of LALR parser will be a set of LR1 items. So in the last tutorial, we have discussed how we will form LR1 items. So the basis for this LALR parser is also the construction of LR1 item. So as I have said, a canonical LR1 parser, from that we are constructing LALR parser. Now first we have to see what is a core. Okay. Now the core of a set of LR1 items are those without look ahead. Okay, now without look ahead, now we will see these two set of predictions as giving L dot equal to capital R comma dollar. Okay, in this core is S giving L dot equal to R. This is the core. We are omitting this look ahead symbol. Up to that we will consider as core. So in a set or in a state, you have to check whether there are any two states having the same core. While discussing that CLR parser itself, I have mentioned that whenever there is a change in look ahead, we have to keep that production in two separate sets, right? So here we are going to merging that two sets or two states regardless of this look ahead symbol. So first we have to find the states which have similar core. See, here we have I1 is the set I1 has L giving ID dot comma equal to. So here the look ahead symbol is equal to. Now we have another state I2 with L giving ID dot comma dollar. So here the look ahead symbol is dollar. So when we take the core, both are having same core. So this is the first state. We have to identify the set of states having same core. So when you identify states having same core, then you have to merge the states. So wherever you see I1, you have to write it as I2. Wherever you see I2, you have to write it as I2. So we are going to combine these two states, I1 and I2, as a new state I12. Okay, so we will find the states in a CLR with same cores, then we will merge them as a single state. Now this is the LALR passing. Everything is similar except for this union. Now input is an augmented grammar G dash, and we have output LALR passing table with same functions action and go to, and construction of LR1 items is very much similar. Here comes the core. So for each core present among the set of LR1 items, find all sets having that core and replace these sets by the union. Union is nothing, simply merging that names. Okay. For set 1 and set 2, you should write 1, 2. Set 1, 2. Now let C dash is equal to J0, J1, etc. to Jm, the collection of set of LR1 items. Now the parsing action for I are constructed from Ja in the same manner as in our CLR algorithm. There is no change in this. And whenever there is a shift reduce conflict, we will say that the grammar is not in LALR1. Now the go-to table is constructed as follows. Now in the go-to table, we know when from a state for a non-terminal, we will go to another state, right? So here, as we are taking the union of the states, we have to consider the union while performing the go-to. So you will understand better when we go through. So this is the grammar that we had discussed for CLR parser. This is the LR1 items that we got. Now see where how many states are there with same code. So when you take the state I3 and I6, they are having the same core. Only difference is here the look ahead symbol is dollar and here the look ahead symbol is COD. So I can merge these two states as a single state. 3 and 6 will form a single state 3 6. Similarly, when you look for the state I4, okay, C giving D dot, I can find out one more state I7 where the same production is there with only difference in look ahead symbols. So I can merge this I4 and I7 as a single state I47. Similarly, when you go to I8, C giving C dot and I9 C giving C dot, see the look ahead symbols are different only here, right? Dollar and COD. So I am going to match these two states I8 and I9 as a single state I89. So this is the explanation that I have just explained. The consider a pair of similar looking states, then replace I4 and I7 by new state I47. Similarly, I3 and I6 and I8 and I9 form pairs. Okay. So this is our canonical LR parser that we have constructed in the previous tutorial. So from this, how I can get this LALR parser. Now see, I am going to merge I3 and I6 into a single state. So we know that shift represents the state, right? Reduce represents the production. So wherever you have 3 in shift area and 6 in shift area, replace it by the new state 3 6. It means that on 0 on C we have to go to state 3. Now we have new state 3 6. So wherever you have shift 3, you have to write as 3 6. That is what here I have written as 3 6. Similarly, wherever you have 6, state 6, you have to write it as 3 6. So I have it written here as 3 6. Similarly, in the state names also you have to change. 3 has to be written as 3 6. Okay. Now after writing this, you will see that 3 6 repeats, because in 6 also I will write 3 6 and here also I will write 3 6. So what you have to do is you have to merge these two states into a single state. Here 3 6, here 3 6. So it have to be merged into a single state, and at that time you have to merge the values in rows. So here we have on 3 we have C, D, S3, S4. 6 we have 3 6 here. Now 4 and 7 will get merged to form a new state 4 7. So in 3 6 you will get S3 6 and S4 7. See, similarly you have to do all this. 4 and 7 has to be replaced by 4 7. 8 and 9 has to be replaced by 8 9. And wherever you have a shift 8, you have to replace by 8 9. Okay. Now in this go to part also, wherever you have 3, you have to write 3 6. Wherever you have 4 or 7, you have to write 4 7. Wherever you have 8 or 9, you have to write 8 9. So this is how we will get an LALR parser. And see here the total number of states was 10. From 0 to 9 it was 10, and here it is reduced to 3 4 5 6 7. Okay, that is how there is a reduction in number of states as well as equal number of states as compared to SLR, because here we are omitting that look ahead symbol. Just we are considering the core. That is why we are getting a number of states similar to that of the SLR parser. So hope you have understood how to convert the CLR parser to LALR parser.